Welcome back. Today we are going to look at section 1.5. We are looking at solving inequalities. So our objectives today are to solve and graph inequalities, and then tomorrow we will look at writing and solving compound inequalities. So to review, we're going to write each statement in words, and then we're going to graph our solution or our inequality on a number line. So the first one here would be read x is less than 2. So if we think about a number line, we want our numbers to be less than 2. To indicate that on a number line, we are going to do an open circle at 2, and we're going to shade all of the numbers on our number line that are less than 2. The open circle is used to imply that we're getting really close to 2, but we have to be just underneath it, smaller than it. Okay, so if we have a less than or a greater than symbol, we're going to use an open dot on our number line. Our second one would be written out as x is greater than or equal to that 5. So on our graph, we want our x value to be 5 or something bigger. In this case, since we can equal 5, we use a closed dot, and then we want to shade all of the numbers that are going to be greater than that 5 or bigger than 5. So if you have less than or equal to or greater than or equal to, you're going to use a closed dot on your graph. All right, third one, we would read that as x is greater than 3. So again, on our number line, we need a 3. You can put some more numbers on either side of it if it helps you. We want our x value to be greater than that. So again, we can't equal 3, we just have to be really close to it. And then we want to be all the numbers bigger. All right. This one we would read as x is less than or equal to a -1. So on our number line, our key number would be the -1, but again, you can put some numbers on either side of it to help you. We want to be less than or equal to that. So since we can equal it, we're going to use a closed dot, and we can also be numbers that are smaller, which are going to go to the left of our key number. This last one here is turned around. We can read it as 4 is greater than or equal to x. Typically, we put the x first. So keep in mind that you can completely reverse this statement. If we turn the whole thing around, we can also say that x here has to be smaller than that 4 or equal to it. So again, we could have written this as x is less than or equal to 4. It would mean the same thing. So our key number on our number line is the 4. If you want to put a few on either side, if that helps. We want x's to be less than or equal to 4. So we're going to do a solid dot at 4, and we want numbers to be smaller than that. All right, so some terms that you're going to see. We've talked about less than, greater than, less than or equal to, greater than or equal to. But some other terms that you might see, at least. If we're talking about something being at least, we're thinking it's greater or more. It's that number or more. So greater than or equal to. At most means that's the highest it can be. So we want something to be less than or equal to that number. You could also have something like no more than. All right, that would be the same symbol, less than or equal to. All right, so our first example here, what inequality represents the sentence? The product of 7 and a number is no more than 50. The word is here, I want you to think as kind of splitting your statement into the two sides of your inequality. On the one side, it says the product of 7 and a number. I'm going to just use x for my number. The product means we are multiplying. We talked about this a couple days ago. So we are multiplying the 7 and an x together. Okay? The is kind of breaking it, so that's where our inequality symbol is going to go. So the statement is no more than. So it can't go over it. So we need to be less than or equal to that. And then the other piece here is our 50. So we have the product of 7 times x has to be less than or equal to 50. It can't be more than it. All right, our second example, what inequality represents the sentence, the quotient of a number and 3 is no more than 15. Quotient again means division. So split our inequality right there. The quotient of a number, I'm going to use x, and 3. So we're taking x and dividing by 3 is no more than, so that's our inequality statement, is no more than, less than or equal to the 15. All right, so we have our inequality statements. The question now is, when we solve equations, is that the same as solving inequalities? Think about that for a second. Do we solve an inequality the same way we solve an equality? There is one exception to them being identical, and that is we must reverse the inequality sign if we multiply or divide by a negative in the process of solving our inequality. So start out solving it just like there's an equal sign, but then be aware that if you end up having to multiply or divide by a negative, your inequality symbol is going to have to be reversed. So a greater than would turn into a less than. All right, our first example is 4 times the quantity x minus 7 is greater than negative 20. We're going to distribute to get rid of our parentheses. So we have 4x minus 4 times 7 would be 28. We have all of our variables on one side, so we're going to get our constants to the other side. I'm going to add 28 to both sides. We now have 4x is greater than an 8. Negative 20 plus 28 would be 8. Our last step to solving this is going to be to divide out the 4. So we end up with the statement x is greater than 2. Now it does say to solve and graph it. So we're going to consider a number line here. 2 is our key number. We want x's to be greater than it. So we're going to put an open circle at 2 and shade the numbers that are bigger than 2. Okay, example 2. Again, we have some distributing to do to clean this up. So negative 2 times our x, negative 2 times the 9 would be negative 18. Plus 5 is greater than or equal to 3. We can clean up the negative 18 plus 5 would be negative 13 if we combine those like terms. All of our x's are on the left, so I'm going to bring the constants to the right side. It's a subtract 13. To undo that, I have to add 13. That gets me the statement negative 2x is greater than or equal to 16. And here's a case where I have to divide by negative 2 to solve this. And because I'm dividing by a negative, my inequality symbol here is going to have to get reversed. So my statement is going to be x is now less than or equal to instead of greater than or equal to. 16 divided by negative 2 would be negative 8. Again, they want us to graph this. We want x to be equal to negative 8 or anything smaller. Smaller goes to the left. All right, our next example, we have a variable in 2 different spots. So our first step is going to be to get all the variables to one side and all the constants to the other. So I am going to subtract the 3t from both sides. So I have negative 3t plus 1/2 t plus 3 is less than or equal to negative 5. I can then move my constant and subtract it to the other side. Negative 5 plus negative 3 would be negative 8. Now, I have a negative 3t plus a 1/2 t. Negative 3 plus 1/2 is going to give us negative 2.5. That gets a little bit messy when we're dealing with mixed numbers in an inequality statement. If you would like, you can multiply everything by your denominator to clean it up. So all I've done here so far is move the 3 to the other side. To clean this up, we could times everything by 2. Multiplying 2 to negative 3t gives me negative 6t. Multiplying 2 to the 1/2 gets me a positive t. And 2 times negative 8 would be negative 16. Now it's a little bit easier to add those together. I have negative 5t is less than or equal to negative 16. And once again, I am going to have to divide by a negative, in this case a negative 5. And because I'm dividing by a negative, my inequality is going to flip or reverse. So t, instead of less than or equal to, will be greater than or equal to. A negative 16 divided by a negative 5 becomes positive. 16 divided by 5. We can write that as a decimal if you'd like. 5 goes into 16 3 times with 1 left over, 1/5 as a fraction, or 3.2 as a decimal. So again, on our number line, 3.2 would be our key number. We want it to be greater than or equal to that, so solid dot going to the right. All right, go ahead and pause the video for a minute and just review those 3 examples. Make sure you understand what we did. And send me an email if you're home and have any questions. All right, moving on. We have problem 3 here. It says a plumber A charges $75 for a service charge and $40 per hour. Plumber B charges $50 per hour but no service charge. How many hours must a plumbing job last for plumber A to cost less than plumber B? All right, so our question right here, we want plumber A to be less than plumber B. So how can we express the charge for plumber A? It says they charge $75 for a service charge. That means just to come to your house, it's going to cost you $75. So we know we're going to have to pay that. Then they also charge an extra $40 per hour while they're working at your house. So let's let H equal our number of hours that he works. All right. So we have plumber A charging us $40 for each of those hours that he's at our house. Plumber B does not charge a service fee, so there's no cost for them to come to your house, but they are going to charge a little bit more per hour. Plumber B is going to charge $50 for every hour that they're working at your house. So our first step is to take our word problem and convert it into an algebraic inequality. And now we can solve this just like we've been doing on the previous examples. We're going to get our variable to one side. So since we have a positive 40 here, we're going to subtract that 40h. We end up with 75 being less than 10h. So when we divide out our 10 to get h alone, we get 7.5 is less than h. Now again, this is turned around a little bit. Typically we start with our variable, so let's read it backwards. We have h having to be bigger than, it's on the bigger side of that inequality symbol, h has to be bigger than 7.5 hours. So for plumber A to be less than plumber B, the job would have to take more than 7.5 hours. Second example of this, a digital music service offers 2 subscription plans. The first has a $9 membership fee, and then they will charge $1 per download. The second has $25 membership fee, but only 50 cents per download. How many songs must you download for the second plan to cost less than the first plan? Okay, the second plan has to be less than the first plan. All right, so let's get an expression for the second plan. We are told here they have a $25 membership fee, so you're going to pay $25 regardless of how many songs you download. And then they're going to charge $50 per 50 cents per download. So we're going to add 50 cents per download. Let's let X be the number of downloads. Okay, since that's what they're asking us to find. All right, the first plan we are told has a $9 membership fee, so much less as an initial fee, but then they are going to charge $1 for every download. So we're going to add $1 for each of those X's. We now have an algebraic inequality. We need to get our variables to one side. So I'm going to subtract the 50 cent X. 1 minus 0.5 is 0.5, or $1 minus 50 cents is 50 cents. My next step would be to subtract the 9 to the other side. 25 minus 9 would be 16. So we end up with 16 is less than 1/2 X. And we can divide out the 1/2, the 0.5. So 16 divided by 1/2 would be 32. So in this case, we are going to have X as being more than 32. So we need more than 25 downloads for that to work out, where the second plan is less than the first plan. Sometimes inequalities have no solution or all real solutions for all real numbers for solutions. So similar to when we solved our equalities, we can run into the question where our variable disappears and we have to look at, do we have a true or false statement? All right. If we have a true statement, we have all real solutions. If we have a false statement, we get no solution. So is the inequality always, sometimes, or never true? The first step I'm going to do is to do some distributing to clean up the parentheses. So 3 times x would be 3x, and 3 times 3 would be 9. On the right side, 3 times 2 would be 6, and 3 times x is 3x. When we go to clean this up and get our variables to one side, you'll notice that they disappear on us. We have a statement 9 is greater than or equal to 6. We have to evaluate that to determine if that is true. Is 9 greater than or equal to 6? If we think of a number line, here's 6, 7, 8, 9. 9 is greater than our 6. So that is a true statement, which means it is always going to work. There's an infinite number of solutions. All right, our second example, 9 minus x minus 5 is less than negative x, or the opposite of x, plus 4. We can clean this up a little bit. 9 minus 5 is 4. So 4 minus x is less than or equal to the opposite of x plus 4. Trying to get our x's to one side, we could add an x to both sides. And now our x's disappear again. We have 4 is less than 4. Now be careful on this one. Is 4 smaller than itself? that is a false statement, which means there is no solution, which means it's never true. If there had been an equal sign here, there isn't one, but if there had been an equal sign there, then we would have said it's true, because 4 does equal 4. But 4 is not less than 4. All right, go ahead and pause the video and try this one. Checking your answer. Distributing gives us 8x minus 12. On this side, distributing gives us 8x plus 8. We can try to get our x's to one side, but they disappear. So look at our statement. Is negative 12 less than or equal to 8? If you think of a number line, here's 0. There's your positive numbers. So 8's going to be over here on the far right. And on this side, we have our negative numbers. So negative 12 is going to be way over there on the left. And negative 12 is going to be smaller than 8. So it is less than or equal to it. In this case, it's the less than part. So this is a true statement. So we'd say always. It's always going to be true, which means there's an infinite number of solutions. All right, we are going to stop there for section 1.5 today. Check your Schoology page for your assignment.